Hey guys, here is your Polar Bears intro, and we'll just do the basics just to kind of get you off and running. And the idea here is we're going to define a curve in polar form. So just a very basic one, the one you probably even started with or something like it, would be when you just know the radius. So the radius is going to be 4 no matter what theta is. So this essentially is just a circle with radius 4. Nothing fancy. Okay, so at 0 degrees you're 4 away, at pi over 4 degrees you're 4 away, at pi over 2 degrees you're 4 away, etc. So this is probably one of the earlier examples that you may have done. And if not, it doesn't really matter, because that's what we're doing now. So the idea here is we're going to focus on finding area using polar equations. So let's just look at a little slice of this. And there's theta. And here's my radius, right, which is the same here. Right, it's just the function. It's r, r of theta, really. R of theta. R of theta. We usually use theta. And whatever that length is your actual, is that radius. So if I want to try to find this sector, well, we could do this geometrically. We take theta out of the total possible, angle measure, which I know you all just said was 360 degrees, but of course I have to correct you because we're using radians. So it would be theta out of 2 pi times the area of the circle. Right, it's this portion of the area of the circle, and that's what we did in freshman year. Okay, except we did use 360. I'll give you that. So the pi's cancel, and you're left with area equals. There's a 1/2 r squared theta, and this is the key to everything because this is the actual area of a sector, whether it's a sector that takes up the whole thing or it's just a tiny little slice. And this is what we're going to need. So if area is 1/2 r squared theta. And that works great for a perfect circle. Well, unfortunately, that's not going to work so great when you have a graph that looks like this. Okay, so let's focus on that for a second. And make that a little bigger so you can see it. So you got some graph that's defined polarly, whatever. And you've got your r here. Right, this is r of theta. Okay, so here is my radius at whatever theta we're going to use. I have a theta here. I'll call that theta 1. And then I have a theta here. That's theta 2. Okay, and I want to find the area of this sector. Now I made it kind of bigger just so you can see it better, but ideally I'd want this slice to be super thin, because at some point I'm going to want to add up all the slices that make up the whole curve. Right? I'll have tiny slices, just like we did with the rectangles. So if I could find the area, let's just find the area of this one piece right here. To find the area of that one piece, I would find the area of this sector here using the big theta, the theta 1. So that would be 1/2 r squared theta 1. And then I'd take away the sector here, and what's left over would be a pretty good approximation, assuming my thetas were relatively close together. Okay, oop, not equals, that's minus. Right, big minus little, right? Big area minus little area is whatever's left over. Clean that up a bit. 1/2 r squared. Theta 1 minus theta 2. Okay, and whatever that is. And that's my area for that slice. But of course, I want to add up an infinite number of slices. I'm sure you saw this coming. This is just like when we did rectangles. It's really no different. We're just slicing it up into sectors instead of rectangles. So my total area then, I'm going to go ahead and integrate this formula, and that'll add them all up. So the integral, and usually we use a and b for the angles here as well. 1/2 r squared, and then theta 1 minus theta 2 is the change in theta, right? That's delta theta. This right here is delta theta. Well, of course, we're going to call it d theta. Same idea. And this is it. This is your formula for area using polar equations. That's it. This is your r. This is your actual, it's almost like your function. Okay? So all it really is just area of a sector. Just add it up a bunch of times. So let's go back actually to the original problem, which ended up over here. And let's take a look. Let's do the area of this entire circle right now. Old school. Old school pi r squared, right? Old school, pi times 4 squared is 16 pi. Okay, new school. New school, I'm going to use my new formula to find it. So the area from, let's go from 0 to 2 pi, like a full circle, right? of 1/2 the radius squared d theta. Well, r is 4. If r was like 2 cosine 2 theta, then we put 2 cosine 2 theta. This is the integral from 0 to 2 pi. That's 16 times 1/2, which is 8. The antiderivative of 8 with respect to theta is 8 theta, evaluated between 0 and 2 pi. 2 pi times 8, of course, is 16 pi minus 0, and there you go, 16 pi. Now, I wouldn't recommend doing it this way for a circle, but it's certainly going to help with ones like this. Okay, so for now, this is just the beginning. This is your intro. That's all you really need for the intro, and you probably could actually do a bunch of them by just seeing this. Obviously, if your comfort level is kind of low with the polar stuff, graphing and knowing how to look at the picture, this you're going to want to look at the other videos too. But just to kind of show you real quick, just to get it in here, since it is an intro, we can go into mode and change our mode to polar. Go to your y equals, and you'll see they all turned into r's. So there's your r, instead of y1, r1, and our first r was 4. Go to your window. 0 to 2 pi, that's already in there, and -5 to 5 should be fine. So actually, I think we're in good shape. We could probably see it right now. And there's r equals 4. Okay, and you can do that again. You can do that with anything. R equals cosine 2 theta graph. Okay, looks like a 4-leaf clover. Actually, you could probably zoom in on that a little bit and see what it looks like. Okay, those have to look familiar. You had to have done something like that before. If not, that's okay. I'll get you through. But that's the basic idea. So we're gonna do, actually we could do one like that in the next example. But this is the basics. Let me know if you have any questions, and I will talk to you guys in a little bit.